This is a fully responsive facade. One curved surface, 121 panels, and every single one of them knows exactly how far it is from this point. Watch what happens when I move it. That's not an animation. That's Grasshopper recalculating 121 values the instant I let go of the mouse. And today, day 14, you are building this from an empty canvas. Every piece of it is something you already know from phase 2. Today, we put all together. Let's build it. Before we can divide a surface, we need one. We are not modeling a real building facade yet, we just need something gently curved to prove the system works. Patch is the fastest way to get there. In the top viewport, type points and press enter. Click 6 to 8 locations across the viewport to create individual point objects. Spread them irregularly rather than placing them in a perfect grid. Press enter to finish creating the points. Switch to a perspective viewport. Select several of the points objects and use the gumball or the move commands to move them upward and downward along the z-axis, creating different elevations. The points should no longer all lie on the same plane. Press escape to finish editing. Select all of the points objects, type patch and press enter. The patch dialog opens and immediately previews the resulting surface. Leave the default setting for this exercise and click OK. Rhino creates a smooth NURBS patch surface that passes through or closely fits the selected points. Open the Grasshopper canvas. From the Params tab, Geometry panel, drag a surface parameter onto the canvas. Right-click the surface parameter and choose Set One Surface. Click the patch surface in the Rhino viewport to assign it. Rename the parameter by pressing F2 or right-click, rename and type Base Surface. Divide surface takes one continuous surface and generates a clean grid of points across it, based on its internal u and v coordinate directions, not x and y. That's the same UV logic used with curves back in phase 1, just extended to it 2 dimensions. Double click on empty canvas and search divide surface. Place a component. Connect the base surface parameters output to the divide surface component's S input. Drag two number slider components range 2 to 20 integers from params to input and wire them into U and V. This makes the grid density adjustable live, which is worth doing since you will want to show different density later. Observe 3 points appear. P, points. N, vectors. Surface normals at each point. UV, the UV coordinates of each point. Zoom into the Rhino viewport. A 10 by 10 grid of points, 121 total, now sits evenly across the curved surface following each curvature. The U and V slider values set the number of divisions, not the number of points directly. 10 divisions in each direction produces 11 points per direction or 121 points in total, 11 by 11. This is a common point of confusion. Call it out explicitly on screen. Everything the panel do, their height, whether they are open or closed, comes down to one number. How far each grid point is from this attractor. So the attractor itself needs to be something you can move freely live in the Rhino viewport. From params to geometry, drag a point parameter onto the canvas. Right click it, choose set one point. Click anywhere near, not on, the surface in the Rhino viewport. Rename the parameter Attractor. Distance is about as little as Grasshopper components get. 2 points in, 1 number out. The straight line distance between them. We are feeding it 121 points on one side and a single attractor on the other, and Grasshopper automatically repeats the single attractor against each point in the list. You don't have to do anything special for that to work. Search and place a distance component. Connect divide surface P output to distance A input. Connect the attractor's parameters output to distance B input. Connect it to a panel. A panel of 121 numbers appears and the distance from every grid point to the attractor. To remap these distances into a clean 0 to 1 range, remap numbers needs to know the real minimum and maximum of the data it's remapping. Guessing that number is how beginners get panels that looks identical no matter where the attractor is. The guess range doesn't match the actual data, so the remap clips almost everything to one end. Search and place a bounce component. Connect distance D output to bounce N input. Connect this output to a panel. A single domain value appears, something like 2.1 to 34.7. Something the real minimum than maximum distance in the current geometry. Right now, distance 0 means at the attractor and the larger number means far away. But we want the opposite for height. Close to the attractor should mean tall, not 0. Remap numbers can do both the rescaling and the inversion in the single step without a separate expression component by simply reversing the target domain. Search and place a remap numbers component. Connect distance D output to remap numbers V input. Connect bounce output to remap numbers S input. Drag a construct domain component with A1 and B0 and connect it to T. Now connect this to a panel. Values near the attractor now reads close to 1, values far away reads close to 0. The field is inverted in the same step it was rescaled. Drag a number slider onto the canvas, set its range to 0 to 5, value 5, name it max height. Search and place a multiplication component. Connect remap numbers R output to multiplication A input. Connect the max height slider to multiplication B input. Connect this output to panel. 121 height values each between 0 and the current max height. Tall near the attractor and near 0 far away. Every panel needs to sit flat against the curved surface as its own point, oriented to the surface local direction. That's not a flat world XY plane. Surface frame does exactly this. Give it a surface and the UV location, and it hands back a plane that's correctly tiled to match the surface at the exact spot. Search and place a surface frame component. Connect the base surface parameters output to surface frames S input. Connect divide surface UV output directly to surface frames UV input. The UV output from divide surface is already the correct data type for this input, so no conversion component is needed. Here's the step almost every beginner gets wrong on their first attempt at this kind of definition, so slow down for this one. The box component in Grasshopper's surface tab is actually called domain box, and through its name, its X, Y, and Z inputs each want a domain, a range with a start and an end, not a plain single number. Plug a raw number in directly and Grasshopper will quietly convert it into a zero length domain, a box with no size in that direction. No error, no warning, just a box you cannot see. Search and place a domain box component. Connect surface frames F output to domains box base input. Drag two number sliders, range 0 to 10, value 10, named panel width, and range 0 to 10, value 4, named panel depth. Search and place three construct domain components and rename X domain, Y domain, and Z domain. For the X domain, set construct domains A input to the negative half width using the division component, which is panel width divided by 2, then negative, and B input to the positive half width. Connect this construct domain output to domains box X input. Repeat steps 4 to 6 for the Y domain using panel depth connecting to domains box Y input. For the Z domain, set A to 0, connect the multiplication output from step 8 to negative and to B. Connect the Z construct domain output to domains box Z input. Now, if you see the panel, 121 solid boxes now appear on the surface, each oriented to its local surface frame, each with a height driven entirely by its distance from the attractor. Now the fun part. In Rhino, click and drag the attractor point across the surface using the gumball. Hold on the live update for several seconds. Every panel height recalculates in real time as the point moves. Drag the max height slider from 0 to 5 and back, showing the full range of panel heights. Save your file as Day 14 Facade System. This is your Phase 2 portfolio piece. Genuinely something you could put in front of the studio critic. Phase 2 is done. You can move a single point and make 121 panels respond intelligently. That's a real skill, not a tutorial trick. Phase 3 starts next, and it's about patterns, arrays, repetition, and a kind of structure, rhythmic geometry you see in a real facade system and a structural grids. Same rigor, new territory. See in the next phase.